We've encountered power in the past, considering the relationship between work and power. It's also important for electricity because electricity, when it is being used, is a form of energy, and the rate at which energy is being used, as we've learned before, is what we mean by power. And when it really comes down to it, everybody has to pay for this energy. And so in electrical terms, as in with other aspects of life, we want to minimize the energy use. But nevertheless, for the time being, we're looking at just how to define this in a physics sense. And so it's the rate of energy flow from a source, which is another way to say the rate at which work is being done by the electrical energy. And that is also a measure of the rate at which heat is dissipated from a resistive element, like your toaster oven. Your toaster oven is basically just a resistor, and if you want that toaster oven real hot, it's going to take a lot of energy in a small amount of time. There's going to be a lot of energy flow into the toaster oven and then radiated as heat, which browns your toast. So it is the amount of heat radiated by a resistive element. So the symbol is P as before. P is work over time, which is the same thing as saying energy over time. And so the units are, well, the units for energy or work is joules, time is seconds. So we have joules per second, and it's got a special name, and it's called the watt, symbol W. All right. So let's look at this again. P is equal to energy over time. Energy is, in electrical terms, charge times volts. Remember, voltage is defined as energy divided by charge. So volts is energy over charge, or energy is volts times charge. So the quantity QV is the energy of the charge Q. Q times the volts. All right. So QV over T. And then we can separate that into Q over T times V, and Q over T is the definition of current. So it's current times volts. Now, current, as we know from Ohm's law, is V over R. You multiply that by V, and you get another form for power, V squared over R. And using Ohm's law, there's yet another way to express this. Here we have current and volts. Here we have volts and resistance. How about resistance and current? Well, sure. IV can be expressed as another way. So substituting for V, we have IR. V is IR. So we have I squared R. And there are our three forms for power. Which one is going to be used in a given situation generally depends on the two physical quantities that we happen to have available to us. Pretty much as simple as that. All right. So IV is coulombs per second. I is coulombs per second. V is joules per coulomb. Notice coulombs goes away and we get joules per second. So that is power. Now let's do an example. We have a 20 ohm resistor, and we want to know the power dissipated by that 20 ohm resistor. Be careful, because as you have learned in circuit analysis, because we have this 10 ohm, the 15 volts is not across here, so we can't just plug it into this and say 15 squared over 20. Nope, that won't work, because we don't have 15 volts across there. So what I'm going to do is go I squared R. If we know the current through a resistor and its resistance, then this is a wonderful expression to use. All right, so we can find I by solving for it in this example circuit with Ohm's law. I is V over R, and in a circuit is R total, and that total resistance is 30. So we got 15 over 30 squared times the resistor in question. I mean, this is the current through that resistor, obviously. So 0.5 squared times 20, 5 watts. Knowing that the power, the rate at which energy is delivered, is 5 joules per second, or 5 watts. How much energy in an hour? Well, energy is power times time, which is, in this case, we got to be careful. I said the energy to the circuit, not just the 20 ohm. So I times V I'm using for power. This is the volts delivered to the circuit, 15, delivered to the 10 and the 20 collectively, and the current. Well, the current we just solved for, it's 0.5. So that makes it pretty straightforward. Half an amp, 15 volts, 3,600 seconds in an hour gives us 27 kilojoules. So there is actually, that energy is what you are paying for every month when you pay your electric bill.